Okay. Hello, everyone. I hope everyone is back. So now we are going to look at the demo. Uh, we're going to look at basically Opti here. What is Opti? Opti is a trusted execution environment which is designed as a companion to a known secure Linux kernel running on ARM Cortex A cores using the Trust Zone technology. So it's a TEE which is designed in companion to non-secure Linux kernel, meaning that the non-secure OS is Linux kernel and it uses the trust zone technology. Opti implements TEE internal core APIs, which is exposed to the trusted applications, and the TEE client APIs, which is the API describing how to communicate with the TE. So there are two uh, APIs. One is the TE internal core APIs, which can be used by the trusted applications, and then the TE client APIs, which can be used by your application which you are developing safe in the non-secure world, which you are developing for the non-secure world. Like in the example slides, we were seeing this Armory application. That Armory application can use these client APIs. So if you're writing your own client API, if you're writing your own client application, and if you want to use TEE, uh, then you can use these T client APIs with Opti. Okay. And these T client APIs are defined in the global platform API specification. So you can look at these documents for more details about what these APIs can offer. Now, the non-secure operating system is referred to as RE, we have already seen, and it's typically a Linux OS. And Opti is designed to rely on ARM Trust Zone technology as the underlying hardware isolation mechanism. So that's what we're looking at. It's a TEE designed using the Trust Zone technology. And looking at the TEE component, if we are going to look at the TE component, yeah, for the TE components, let's refer to this figure. Okay, here. And so this is how your Opti, this is how your Opti view will be. So I'm basically what I'm saying is that if you have a system and if you run Opti on your system, then this will how your system is going to look like. There will be trusted applications which will be running here in your secure world user mode. Then there is a TE internal core API library which is used by these TA applications to talk to the Opti OS, and the Opti OS can talk to the secure monitor, and the secure monitor is actually implemented as an ARM trusted firmware, and the ARM trusted firmware allows the switching between the normal world secure world, and this can be called you can switch from this to the secure monitor with the SMC call. Okay. Now in Linux, there is in the Linux in the normal world here, the Linux kernel has a opti driver. So this code which usually will be doing the SMC calls, basically invoking the SMC instruction. This code is sitting here in the opti driver, which is going to talk to the ARM ATF by making a SMC instruction by switching the control using a SMC instruction. Now, your client application, let's say you have written like you develop a payment application that will be running here. That application can use the TE client API libraries to leverage the TEE. So these API libraries can be used to communicate with this Opti driver, and then the Opti driver will, on behalf of client application, will um, pass control to the secure monitor. And so when your client application say CA1 talks wants to talk to the TA application 1 or want to start this application, then it will have to specify that this particular call is to say talk to application number 1, and these are the arguments and so on. So it will have to specify that information and pass those parameters. Those parameters will then be passed to the application, and the monitor is going to look at the SMC arguments, and based on the arguments it is going to um, on the basis of the argument, it is going to decide whether the SMC call should be passed to the OS, or like basically this is asking for some function which has to be handled by the operating system or by the trusted applications, or it could be just a call to the secure monitor as well to do something. So that depends on what parameters are you passing along in the SMC instruction, and this is how your system will look like. Okay, now how can you how will you use Opti? So Opti has a very well written documentation. Okay, you can, if you're interested in working with Opti, then you all you have to do is then you can go here and you can start looking at the documentation. The documentation here will, you can read the documentation and learn how these different things are implemented, like the MMU for ensuring that this memory safety, SMC, shared memory, etc. So you can go and learn about these different things like secure boot, secure storage, etc. Currently what we're looking is at build and run. So if you want to build and run Opti, then you'll look at this page. First of all, there are some prerequisites that you need. So first of all, you can build Opti only on a Linux distribution. And currently, I think it is mainly supporting only Ubuntu based distributions. And like currently Ubuntu 22 and 20. The other older distributions have been, they're not currently supported. So you have to have one of these two. After that, and you will have to install all of these libraries. These are the prerequisites. So you will have to install all of these libraries. After that, your Opti basically supports a variety of devices. So you can install Opti on a variety of devices, and these are the devices like AMD, Linux, Vercel, the developer box, FVP, Hikey, boards, QEMU, and your Raspberry Pi, etc. So I personally have earlier worked with Raspberry Pi. Chemo is of always very useful because it's just an emulator, and you can quickly it's so it's just an emulator, so you do not need any hardware. Currently I'm working with fixed virtual platforms. So if you do not want to, like if you do not have a hardware, and so then you can, and if you just want to test and learn about Opti, then you can work with Chemo. Okay, any one of them, and you can also work with FVP. It's also a virtual platform only, so it's also emulator. After that, let's say if you want to install for Chemo version 8, then you can open the Chemo version 8 instructions here, which will tell you how to run Opti using Chemo for ARM v8. And then you have to create a Opti. You create a directory, you go inside the directory, you init the repo, and you are going to uh, this is going to, you are going to get the code of Opti from GitHub. After that, you are going to go inside the build folder. First, you do make the tool chains and then you make run. So I've already done these steps. The first step was to install the prerequisites, and then after that, I have already done these steps. And then let's see now, we are going to make run and then see what happens. Okay. So we are here. So we have this folder OptiChemo, and this is a structure of your folder. You have a build folder inside it. You have Linux, where your Linux OS is stored. You have Opti examples. These are examples for client and trusted application examples. Then you have your tool chain here. So you are working with ARM v8 here. So you need to have the uh, ARM binaries and all, like ARM tool chain is here. Then this is the Opti OS is here, and the trusted firmware, which is basically your secure monitor. So your secure monitor is actually here the trusted firmware. So trusted firmware is used as a secure monitor. So let's go inside the build, and here we have these make files basically for different these we have the make files, and we have these different platforms. For different platforms we have different files. Okay, like for Chemo V8 we have this file. Now what we are going to do is to make run. So when we to make run, it will start compiling, and since it is already compiled, so it will take less time to compile now, and we have not made any changes, so it should happen fast. But once, when you are going to compile it the first time, it may take longer. So let's see. Yeah, so compilation is finished. And if you will see here, then it says Kimu is now waiting to start the execution, and start the execution with either a C followed by enter in Kimu console, or attach a debugger and continue from there. So you can actually even attach a debugger such as GDB with this. And there you can find in documentation steps to attach a debugger, and that will help you to debug if you're doing any development on on Opti. But here we are going to just pass C, continue, and then it will start continue execution. Now what it is going to do is that it is going to start two terminals, one for the secure world and one for the normal world. Mhm. That is odd. Let me just restart it. Meanwhile, what we can do while it's starting, let me go and not on this machine. Okay, let me try it here. Uh, it was working earlier. I don't understand the problem. So here we are going to look at now these opti examples. I hope that determine that it starts executing. So if you will, if you want to look at examples of like how you can use these client APIs, TE client API and TV internal APIs inside your, say, trusted application in the secured world or your normal application in the normal world, then you can look at these examples. There are few examples: A cipher, AES, hello world, htop, random, secure storage, etc. And then you can use them to get started. So here we are going to look at the hello world application. And in the here we have these two folders, host and TA. So your host folder contains the client application. Basically, host means the normal world. So the normal world application is stored in host, and TA contains your trusted application in the secure world. So you are going to say go to the host. It's not working. Let me restart my terminal. Mhm. Okay. Hmm. Okay. So I can actually show you the working on another, but actually that I was probably this will make and run, but then I don't think we can. Hmm, okay, also there's some issue. Hmm. Okay, I don't know why it's not working. There is no error, but maybe I can just for now then show you uh, that this is actually I have looked at this earlier today. It was working at that time. But this is your main.c file. Okay, this main.c file, it will be your client application, which is going to be running in your normal world. And this client application here is you can include the T client API library. Okay, this is by including this header file, you can use the T client APIs. And your TA application, which is the trusted application that you are going to invoke from this particular client application, you have to know the UUID, the unique ID of that application. So every TA application is identifiable in like Opti with a unique ID. So you have to give a unique ID to that. So it's saying that this header file has that unique ID. And then you in this main function, if you will go, then these are different these are different objects, like for store get for the result, for the context, for the session operation, etc. So first, when you are want to talk to the TEE, you have to initialize a context to connect to the TEE. And for that, the client API is TEC underscore initialize context. And then this is you for initializing the context. Then after that, you open a connection with the TA application that you want to talk to. So to open a session to the Hello World TA, the you have to pass here the UUID of that application you want to talk to, the TA application, and then it will open a session. And after that, you can actually invoke this TA to you can invoke this trusted application by this command TEEC underscore invoke command. So if you are going to use this API, and if you're going to you have to pass the session information that you had received from open session. So you have here passed it these basically pointers. So you are going to get the value back and these will be filled. So then you will have to pass the session information. You will have to pass here, you're passing some parameters here after that. Okay. And so then the TA application will be invoked, and this is actually the command. You are telling the TA application that I want to perform this command, and these are my operations. For example, I want to, this is the command increment value. So it is going to increment the value of the parameter that you are passing. So if you're passing here parameter like 4200 here, okay, in this op structure, or this is your operation structure, TEC operation structure. So you are initializing it with some parameter. First parameter type you have to initialize. The parameter type you are initializing here as value, in, out, and then none, none, none. So you can pass here 4 parameters, and you're passing for first parameter as the in out parameter, and it's a value. What does in out means? In out means it will be used as an input, also as an output. So when the TA is going to take this as an input, and it is also going to use it as an output. And the what you're storing it in this is actually is just a value. And then you are going to uh, store your value into the params array 0, and then you're saying it's a value, and you've given it a name A. So that's you're storing, and then you're passing this structure, operation structure here. This is your command that you want your TA to do, and this is the session information with the TA, which will be used to connect with the TA. After that, when the TA, if this invoke command executes correctly, then the result will be sent back, which you can see here. The result will basically it's you can compare it with this compare it and check whether the TA executed correctly or not. and then you can print the value of the operation parameter that you had passed. If you see, then if you print it here, then this value would have been incremented actually. If you passed 4200 here, you said invoke command, you did this invoke command. When you will print afterwards, this value would have been incremented. Now this TA also supports one more actually command, which we should see. Not running. It's very weird. Yeah, so in the TA folder, you will see that this is the trusted application code. Okay, this is your trusted application code, and it has these different functions like create entry point. It will be called to when the instance of TA is created, when a new instance is created. This is the first call in the TA. This is called when the instance of the TA is destroyed. Uh, this is when a new session is opened to the TA. Okay. And this is when the session is closed. And now this is your increment value function. This is your decrement value function, which is going to take the parameter and decrement it, the value. And you must note that the parameter types which you are passing from the type of the parameter that you're passing from your client application to your TA, they must match. Okay, they must be same. Otherwise, you will get errors. And the invoke command entry point. So when you call this function invoke command in your client application, this is where this is the function corresponding to that which will get called. This function is going to uh, take the command ID. So you're passing it a command ID, which is either a TA hello world command increment value or TA hello world command decrement value. Based upon this value, it is either going to call the increment value function or the decrement value function. So this these are two like examples, simplest example of using the client APIs for using the TE APIs. Unfortunately, I'm not able to show you the working demo for Opti. And let me try once more. I don't know. So maybe I can reboot my machine and then try it. So let me see. I will. Mm, okay, so mm, mm. Okay, so unfortunately, I think I am. So this is not working right now. So maybe I should then do it tomorrow. Anyways, I have discussed uh, all the details that I wanted to talk about this. So it would have been better if I could have run this and then showed you. But this is if I have told you about Opti, and then if you want to get started, if you want to just try out how you can write your own client application, T application, then you can get started with the Opti examples. And if it if I will try to debug, and then I will show this tomorrow morning. And yeah, if you have any question, then please let me know now. Yes, so this is yeah, earlier I thought that it would be 3 days, but then and I had earlier added an optional Q&A for tomorrow. Tomorrow I will be taking only in the morning, not full day. Tomorrow earlier I had planned to keep it as an Q&A, but there are some things which are left. So um I can take questions tomorrow morning, and otherwise I will. So this demo didn't work now, so maybe I can show this tomorrow morning, and after that I can talk about attestation, like control flow attestation. So that will be only in the morning, and yeah. Does anyone have any other question? Okay. Uh, but it will be recorded. So the session will be recorded. I will be sharing, I can share that. I hope that should be okay. Yeah. Yeah, it had like I was not able to cover what I had planned, but I will be recording and it won't be a very long session tomorrow. It's just in the morning. So it's okay. I will share the recording. In fact, I'm recording all of these sessions, so it will be recorded and I will post the links today to all of the recordings. Uh, no, actually, unfortunately, I cannot provide a certification because I am only a student here and I am doing this, conducting this workshop not as a part of my institute. Like it's not being held by the institute, I'm organizing it on my own. So, and I don't have the authority to provide a certificate. So unfortunately, I am very sorry. I will not be able to provide a certificate for the workshop. So does anyone have any other questions? Okay. So I will post the recordings links here, and I will also post a link to the feedback form. So thank you everyone for joining and keeping it interactive, answering the questions, and it was really good to see the response from you. And so this was my first experience conducting such classes. Basically, the first time I'm doing something like this, uh, some teaching. So I'm sure there is scope for improvement. And so I'll be posting a feedback form here, and it would really help me if you can fill that and give your feedbacks. And apart from that, I hope that whatever we were able to cover since in these 3 days will be helpful to you. Tomorrow's session I had kept as an optional Q&A session. So if you have any questions, then please feel free to join. Uh, if there will be, then I will send the emails like I did. I will send like publicize that. I do not plan to do it in the near future, probably next year or so. Uh, yeah, based on the feedback, maybe I will decide whether I want to do it or not. Okay. And I hope you found the workshop useful and it made some like it was helpful for you in some sense. And just feel free to write to me if you have any questions regarding anything we covered. If you have any questions and if you want to ask them tomorrow, then you can join tomorrow. If you have classes tomorrow, then please do not take leave. You can attend your classes, and I will post the recording here. If you want to join, then please join tomorrow. It will be only from 10 to 1 p.m. Okay, maximum. I may end early also. Depends on like I may not cover so much. I will just do the demo, which I was not able to show today, and then followed by control flow attestation. That's the plan for today. And thank you very much again for joining. And if you have any questions, then please let me know. I'm available. Okay. So if there is no question, then we can stop here. Thanks everyone for joining. And yeah, so thank you again for joining. And I hope that it was a useful experience for you. And I hope that you learned some security, and it will help you in the future. Thank you very much. Thank you very much. Yeah, it was actually, I'm really happy that you people were actually listening and you were replying to the answers. It was very good to see the response from your side. So thank you for making it uh, engaging. And yeah, thank you for joining the workshop and making it successful. It is not possible without you joining every day and then uh, trying to understand what I am saying. So thank you, everyone.